Hello again. Now we will be exploring the twin modules together. You can also access how the twin modules work from the portal as well, and you can show it to your students. And now, firstly, I'll be showing you where you can access this information from the World Science Movement Term 1 section. However, you can also type twin modules to the lessons or videos part, and you will be able to access how the twin modules work video or lesson through there as well. If you go to the World Science Movement Term 1, you'll see that there are loads of lessons. For example, how the twin modules work, dimmers and control modules, exploring sound sensors. Here you will have videos explaining how the modules work and how they interact with each other, as well as experiments in order to understand how these modules work better. Now we can explore the set. First, we can start with opening our twin set. Here you can see that there is a what's in the box outline. There are pictures of every module that's in it. This will also make it easier for you to put everything back together after using them. We can start with our power module. This is the gray one. So this is the USB power. You can power the module using any power source that has a USB insert. So the module has a micro USB insert. So when you're putting the cable in, it should be taken into consideration that the cable and the insert are aligned so that it doesn't get hurt. This is a good point to keep in mind when working with the kids so that they don't use excessive force. So we have our power bank here in order to power the circuit. And if we connect them, we will see that when we change the button and put it to on, there will be a green light. So the gray module is our power module. And if we continue, we'll see that we have our blue, red, and yellow modules as well. We can start with our blue modules. The blue modules are used to convert the energy into outputs. For example, if you connect one of the blue modules, which is the buzzer, with the power, it will create a sound converting the energy into sound. You can also see that if you're trying to connect the modules together from the wrong side, the magnets will push each other away, which means that you will just have to turn it around and they will connect very easily. So if we power the circuit up, the buzzer will turn the energy into output, which is sound in this case. Now we can continue on to the other colors. For example, the yellow ones. The yellow modules are the control modules. So after you connect the power source with one of the output modules, you can use one of the yellow modules. For example, the slide dimmer. This way you can control the intensity of the output. So for example, again with the buzzer, if we connect it to the it has to be in between. If we connect the power module to the control module, and after that, if we add the output module, we can see that as I increase the slide dimmer, the sound intensity also increases. Lastly, our red modules are used for transmission and logic. So if we connect our power module, a control module, which I'll be using the button, and another output module, which I'll be using the LED this time, and if we connect the button, the latch, and then the LED, when I press the button, I will not have to keep pressing the button in order to keep the light on. I will just have to press it once. In this experiment, we'll be exploring our sound sensors and creating an accessible doorbell for hearing impaired people. Inside our World Science Movement Term 1, we can see that there is a lesson called Exploring Sound Sensors. If we get into that one, we can again, as always, see our learning objectives, the introduction, materials, curriculum alignment, sustainable development goals. And if we go down, we can see that there is a Make an Inclusive Doorbell Challenge. In here, you can see the steps into making this doorbell, but right now we'll be doing it together using our twin set that we have right here. First, we'll be starting with our gray power module. We'll again be connecting this to our power source, which is our power bank. So if we connect this and put it to on, the green light will get on. Then we'll be connecting our button. After we connect our control module, so the button, we can connect this to our buzzer. We'll be using this buzzer as our normal doorbell. So if we press the button, the buzzer will go off. Then we'll connect this to our wire and using the wire, we'll be connecting it to another control module, which is a sound sensor. Before we finish our experiment, I want to give more information about the sound sensor. So as you can see, there are two modes on the sensor, mode A and mode B. When the sensor is on mode A, this means that the transmission is done according to the intensity of the sound, and the sensitivity of the sensor can actually be monitored and changed using this button over here. If I turn it all the way to the left, the sensitivity is at 0 and it cannot detect sound. And if I turn it all the way to the right, it's at the maximum level. And if the mode is on B, this means that when sound is detected, the transmission will be done after 4 seconds. Now we can continue on our experiment. Then we will again connect the wire to the buzzer and then the other side of the wire to our sound sensor, so the control module. And lastly, we will be connecting our LED, which is the light output module. This way, when sound is detected, there will be light to make it known that the doorbell has been rang. Let's see. Now we can try if it works or not. So when I press the buzzer, this will imitate the doorbell and the light will turn on when the sound is detected by the sound sensor. In this experiment, we'll be exploring the proximity sensors and we'll be creating an imitation of a car parking sensor using the twin sets. So if we go to the World Science Movement, and we're going to be seeing a lesson called Exploring Proximity Sensors. If we get into that one, similar to the previous lessons, we'll be seeing an introduction, learning objectives, materials, curriculum alignment, and sustainable development goals that are aligned with the lesson. And if we scroll down, we'll be seeing a video, Parking Smartly with proximity sensors, and then a challenge, making a parking sensor, which is what we'll be doing right now. For this experiment, we're going to be using our power module, and then we're going to be using our buzzer, bar graph, and our proximity sensor. Before we start, I want to give a little bit more information about the proximity sensor. So as you can see, again, we have our A and B modes. If the proximity sensor is at mode A, this means that the energy is transmitted when there is nothing close to it. And as we get closer to the proximity sensor, the energy is going to stop being transmitted. And if we have it on mode B, it's going to be the opposite. As we get closer to the proximity sensor, it's going to start transmitting the energy. And we can also see that there are two LEDs on this part over here. These LEDs, one of them transmits and the other one receives the infrared waves. And this way the proximity sensor is able to detect distance between what is coming closer or getting farther away from it. So now we can assemble the circuit. First, we're going to put together our proximity sensor and our power module, and then we can put our output modules, the buzzer and the bar graph. We can also, since the modules are similar to Legos, we can put this over here. I'll turn it over here so I can get it closer. And now we turn it on. Since it's on mode B, as I get closer to the proximity sensor, similar to when you're parking your car, there's going to be sound and there's going to be light increasing as I get closer. Now we'll be exploring our motion sensor using the revolving door experiment. Again, you can reach this experiment from the World Science Movement Term 1 section in the portal. If you go to the Exploring Motion Sensors, you'll again, per usual, see the lesson plan, learning objectives, materials introduction, curriculum alignment, and the sustainable development goals. If you scroll down a little bit, there will be a video explaining seeing infrared, and then there will be a make your own rotating door experiment, which you can do with your class, which we'll be doing right now together. For this experiment, we'll be using our power module, motion sensor, DC motor, and then a wire. So I first want to talk a little bit about the motion sensor. Again, similar to the previous control modules, we have two modes, A and B. Mode A transmits energy when motion is detected, and mode B stops transmitting energy when motion is detected. In addition, the shape of the sensor helps collect the infrared rays from all around the sensor and not just from one point. So when a ray comes from the right side, top hand side, from the left, it doesn't matter. It can all concentrate at the focal point due to the shape of the sensor. Now we can start our experiment. Firstly, we will be connecting our motion sensor to the power unit, and then we'll be connecting our wire to the motion sensor and the other end of the wire to our DC motor. We have to make sure that the DC motor is in analog mode and not coding, since we're not going to be using the coding module right now, but we will be getting into that in the next videos. Our goal with this experiment is to make the DC motor start working when motion is detected. So we will be keeping the motion sensor at mode A. Now we can try it out. So when I put my hand closer to it and make movements, the DC motor starts working. And when I pull it back, it should stop after a while. So after we wait for a bit, the DC motor stops working after motion is not detected anymore. So in this experiment, we're going to be exploring the light sensor, and we're going to be imitating a night lamp. Similar to the previous experiments, we can find how to do this one on inside the World Science Movement Term 1 folder as well. If we go to the lesson called Exploring Light Sensors, you'll see that again we have our introduction, learning objectives, materials, curriculum alignment, sustainable development goals. If we scroll down a little bit, we will see the video called Light Up the Nightlight. This is the informational video, and right next to it there is a make your own nightlight experiment. Let's try if it works. I'm just going to cover the light dependent resistor with my hand to create a darker environment. And as I make it darker, the more LEDs get brighter on the bar graph, and the LED gets slightly brighter and brighter and brighter.